Hi. We've talked a lot about different types of evidence, and we said statistics form one really good form of evidence. But there's something special about statistics that make it especially important for us to talk about in more depth. And so today's lesson is about statistics, a powerful technique of persuasion. Part of the reason statistics are so important is that digital media, that because of digital media, two new forms of persuasion are really very easy to use. One is images. Okay, this is an image from the Syrian war, and images are easy to produce, distribute, and access and put into your essays. And notice how powerful this image is. This image went around the world. It really brought home for a lot of people the shock and horror of the Syrian civil war. And images are just great. They're very effective. And it's because of digital media, computers, internet, that we're able to use them so much. Likewise, statistics, very different. It doesn't have the visceral appeal of images, but still very powerful. So this statistic, half the country's pre-war population, more than 11 million people, have been killed or forced to flee their homes. Because of computers, we're able to store, access, distribute, and incorporate statistics also more easily and effectively. Like images, statistics have to be used very effectively. They can be done effectively or not effectively. They can be used deceptively or honestly, and it's really important that we understand some of these different rules. So we're going to talk about some different principles about using statistics. So context matters. That's the first most important principle when you're using statistics. If I tell you that the price of tea in China is 150 renminbi per 500 grams, that makes no sense to most of us. What kind of information do we need to be able to make sense? We've got to know what a renminbi is and how much it's worth and how much you can buy with a renminbi. 500 grams. I'm American. I don't know grams. How much tea can you make from 500 grams? What else can you buy with 150 renminbi? Historical trends are really helpful. Is that a lot? Has it gone up? Has it gone down? How does that compare with other countries? So different kind of comparison points. And even more basic, why does that matter? Why do I care about the price of tea in China? What issue is it relevant to? It may even be important to define terms. What kind of tea are we talking about? What kind of range of prices are there? I'm sure there's not only one kind of tea with one kind of price. So here are some important things about context that are fundamental whenever you're presenting. You've got to realize who would care and why. What issue does a statistic relate to or prove? What kind of historical comparisons can we use? What kind of comparisons with similar things or familiar things? Different countries, different products, things like that. Percentages versus raw numbers, we'll be talking about that in more detail. Definition of terms, how much, what kind of tea are we talking about? So all of those are really important aspects of providing context. So take a look at these statistics. My face out of the way here. And if I said, well, what kind of information is needed to make sense of these statistics? All right, so pause your video for just a minute, and I want you to read each of these and think about what kind of context would be helpful to make sense of these things. So let's think about number one. There are 55,000 undocumented immigrants living in Federal Bureau of Prisons facilities. Okay, so first of all, you have to think about what issue is this relevant to? And it's relevant to the issue of whether undocumented immigrants bring a lot of crime. Donald Trump and some others have argued that illegal immigrants bring a lot of crime to this country. Others say nonsense. They don't commit any more crime than other Americans. In fact, they commit less. So how do I know what is this? This is proving one side or the other. So one thing I want to know is, what are they in prison for? Is it just for violation of coming across the border illegally, or is it for other crimes, you know, murder and robbery and things like that? Okay. A comparison, okay? Has this increased or decreased? Percentages would be really helpful. As a percentage of all the prisoners in the Federal Bureau of Prisons, what proportion is this 55,000? And how does that compare with the population of undocumented immigrants? I know there are, I think, 11 million undocumented immigrants, they think, in the United States. What percentage of the population does this represent? So in other words, are they overrepresented or underrepresented in their share of the population? Also, I want to compare with other prison systems. Is it similar in other prison systems, or are most undocumented immigrants put in the Federal Bureau of Prisons, so there aren't many in the state or local prisons? What's the overall cost to incarcerate these people? Those are kinds of information I want to know. Number two, undocumented immigrants pay $11.74 billion in state and local taxes. So what issue is this relevant to? It's relevant to the issue of whether undocumented immigrants pay their fair share, or they use too many services and don't pay anything in taxes. So I know, okay, they're paying some in taxes. What would I want to know? Compare that with the past, maybe compare with the percentage of overall taxes paid compared to legal immigrants or citizens. In other words, are they paying their fair share as a share of their population? How much in federal taxes? It doesn't show anything. Why is it only showing state and local? And I'd want to compare this with the benefits that they gain. Okay, they pay this much in taxes. How much are they receiving in benefits? Number three, undocumented immigrants use services at twice the rate of comparable natives. Again, this is the same issue. Are they using services too much? Are they taking advantage of the system? Are they a burden to the public system? So what kind of information might I want to know? Well, what kind of services are we talking about? If we're talking education, it would really surprise me that immigrants are using education twice as much as non-undocumented immigrants, but maybe that's not counted, okay? What kind of services are counted? And that word comparable, that's a really odd term. What do they mean by comparable? I may want to compare past and present. How much in total dollars per person does this mean? But especially the word services, the word comparable, those are real key issues I'd want to know. Number four, well, what's the issue here? The issue is the United States admitting not enough Syrian refugees, too many Syrian refugees, just the right amount? It's relevant to the question of the travel ban and whether we're doing our fair share at helping out with this refugee crisis. So I'd want to know, well, in comparison with past crises, we've had refugees from Vietnam, Cambodia, and Laos. How does this compare with that time when we accepted refugees from those countries? We've accepted refugees from Cuba, all over the place. How does this compare? How does this compare with other countries? Are other countries taking more as a share of their population and wealth? And how does this compare with the total number of people needing refuge? Number five. So number five, the issue is, are we admitting too many guest workers? Are these guest workers taking jobs that Americans could do? or do businesses really need these workers? So one thing I want to know is some of the terms, okay? H-1B visa, what exactly is that? What fields are we talking about that they're going into? What kind of jobs? I bet they're not going into CEO or politics, right? They're probably taking jobs from you and me, if anything. But is it a job that's really low demand or high demand that we maybe don't have enough employees? I don't know. How much are they making? How long do they stay here? How long is this visa granted for? Is this per year, or is this the total number who have accumulated over the years? What happens when the visas expire? And let's compare this. Let's compare the past, compare with the unemployment rates in those fields, the number of people looking for jobs, the number of openings, the salary, things like that would really help us understand. So, principle number one is context. We've got to have context, all right? Principle number two is that you need to paraphrase accurately, all right? A lot of my students, they give me a statistic and they paraphrase. I like how they're paraphrasing, not just directly quoting. Remember, you want to try to paraphrase rather than drop in tons of direct quotes, okay? But you got to paraphrase it accurately. So again, I'm going to have you pause your video in a minute, and I'm going to have you look at the sentences on the left. Which of these paraphrases are accurate for the data on the right? Now, let me just quickly go through the data on the right. This little graph, number of alien removals from 1989 to 2013. And it shows this graph is the total number of removals. And you'll see this is in the Obama era. Removals really increased quite a bit. And but they broke it down. They broke it down into this top shaded, that's border removals, people who were removed at the border. Interior removals, that's what you see with ICE, that's people removed from, say, Stockton. ICE comes to Stockton and takes somebody away who's an illegal immigrant, okay? So take a look at this, and this is all referring to basically 2013 mainly, this last bar here. And pause your video, take a look at this, and then look at the paraphrases, which is accurate. So, number one, this is totally inaccurate, okay? 369 illegal immigrants were deported. No, this is 369,000, all right? Totally wrong. Number two, in 2013, 64% of all illegal immigrants were deported at the border. No, 64% of all illegal immigrants. Okay, there are 11 million illegal immigrants in the country. 64% were not deported at the border. No, most of those people are still here. And if you're only talking about the people who were crossing at that time, this is not telling you how many were crossing or how many got through. We don't know exactly how many got through. So we don't know that 64% of them were deported at the border. What this is saying is that of all the deporting that happened, 64% of it occurred at the border. And that's what number three is. That's correct. In 2013, about 2/3 of all deportations occurred at the border. That's right. 64% is about 2/3 of the total, and that's of those of all deportations, that 2/3 at 64% occurred at the border, not in the interior of the country. So number three is accurate. Number four, in 2013, almost twice as many removals occurred on the border. Well, it's a little imprecise, is my argument with this. Twice as many removals occurred on the border as what? Twice as many as what? It's not really clear. You'd have to add almost twice as many occurred at the border as occurred in the interior of the country. Then that would be accurate. So it's a little imprecisely stated. Number five, the number of removals dropped from 64% to 36% between 2008 and 2013. No, I think they're referring to this 64% to 36%. No, that's not the number of removals that dropped. It's the share of removals that occurred in the interior of the country versus at the border that dropped. In fact, the total number appears to have been about the same. It peaked and then it dropped back down, and the total between those years is the same. In 2013, most illegal immigrants were caught at the border. No, most illegal immigrants probably slipped right through. In fact, most illegal immigrants, or a lot of them, 40% of illegal immigrants don't come across the border. They fly in and they overstay their visa. So no, most illegal immigrants were not caught at the border. They're saying of those who were deported, most of them were caught at the border. So be really careful how you paraphrase. It's really important. So we've seen context matters, paraphrase accurately. Principle number three, present your statistics effectively. And I recommend you do this thing called a statistic sandwich. Well, this is just like your use of sources. You don't want to just drop your sources in. And we said, set up your sources with a generalization first, then give your quote, and then explain how that quote supports your generalization. Same thing with a statistic, okay? It's the same principle. Start off with your generalization, give your statistics, then explain the significance of that, okay? Look at this example. If the government reduces immigration, it will also be cutting off a significant amount of future brain power, okay? There's my generalization. A new study from the National Foundation for American Policy found a remarkable 83% of the finalists of the 2016 Intel Science Talent Search were the children of immigrants. So it's not the immigrants, but their children who are science talents, okay? There's my stat, then my explanation. This means that immigrants not only bring unique talents to this country, but their children are also super achievers, okay? So this is explaining the meaning of that. That's a statistic sandwich, okay? All right. Another principle is to beware of biases. Your own biases, and we're doing a lot of work in this unit on biases, but watch out for other people's biases as well. And when you and your author both have the same bias, it's a great opportunity to be fooled, deceived, and for you to perpetuate lies. So, I remember having a colleague tell me, you can't argue with statistics. Well, you can actually. And in this kind of second half of this little lesson, I want to talk about how you can interrogate and try to analyze and understand statistics to see how they might be used in a deceptive way. And the first one is average. Average seems like it's straightforward, but it's actually an ambiguous term because there are different kinds of averages. The kind we usually mean is called the mean average. That's where you add up items. Let's say you've got people age 10 and 12, 14, 16, and 18. You've got these different ages. You've got 5 people, these different ages. You add up all their ages, divide by 5, and the number you get is the mean average. The median is the middle number between the top and the bottom. That middle number is the median, and the mode is the most common number. So let's say we take this, Slakey Brothers Company. Here's my company. We've got an owner, makes $1 million, 2 top managers at $200,000 each, 5 skilled workers at $50,000, and 7 heavy lifters at $20,000, all right? So pause the video for a minute and try to calculate the mean, the median, and the mode. So here's our answers, okay? The mean, we add up each of our workers, our owner, 2 top managers, 5 skilled workers, and 7 heavy lifters. We've got a total of 15 workers. That's a mean average of $106,000, okay? Average salary is $106,000. That's a true fact, okay? The average is also $50,000. That's the middle number. The most common number, if you listed all the numbers up and down, 50,000 would be right in the middle, okay? And that's the median. Mode is $20,000. It's the most common number, all right? So if, let's say, Slakey Brothers employees are going on strike, and the news reporter comes to the owner and says, well, what do you think? They say they don't make much money. He says, poppycock, the average salary is $106,000. They're a bunch of whiners, all right? And then they go to the union and they ask, why are you going on strike? Oh, the average salary is only $20,000. How can anybody live on that, all right? So you get the idea. Average is a very deceptive term. Take a look at this little graph, victory in war by president's party. Study this for a little bit and try to identify what the writer is trying to prove and ways in which this might be deceptive. Some of the things you could look at that would show how this is deceptive. So pause the video for a minute, think about it, and then we'll talk about it. All right, so first thing to notice is the writer's trying to prove something. Democrats kick ass, Republicans are wimps, all right? That's our first thing to try to recognize. Where's the author coming from? What's the bias? Some important ways that this could be considered deceptive is, first of all, how terms are defined. Always look at the definition of terms. For example, victory, okay? Victory, victory, victory. How is victory defined, okay? The Iraq War is considered a democratic victory. Why is it a victory, number one, and why does a Democrat get credit for it? Vietnam is considered a loss. Okay, I could see that. Why does a Republican get credit for that? The war was started under Kennedy, really, and especially Johnson, and ended under Nixon. Why is it a Republican loss? Okay, so how you count things, who gets credit for the victory or the loss, how you define a victory or loss, how you even define a war. Okay, World War I and II, those are definitely wars. Okay, Osama bin Laden, that's not quite a war. Notice what else is eliminated, left out. We attacked Grenada. Okay, I don't think it was an official war. We kicked their butts. Look, tiny Grenada, they had no chance against us. Why is that not counted? Okay, so why are we counting certain things and not counting certain things? Watch out for what we call cherry-picking data, where you pick the data you want to prove your point and you ignore the data that you don't want. And notice the start date and end date, 1912 to 2012. We're cutting it off, and it's an even 100 years, but if we went to before 1912, well, we'd have a couple of Republican victories, and we might have some Democratic losses after that. All right, so where you pick and choose, how you count things, how you do all that is called cherry picking. And then most important, there's an implication here that the Democratic president caused the victory and the Republican president caused the loss. What fallacy is that? Can you think about it? It's the post hoc fallacy. Just because the Democrat happened to be in office at the time of that victory does not mean that the Democrat caused the victory, okay? That's the post hoc fallacy that we've talked about before. Another way that you need to be really careful is with raw numbers and percentages, okay? So let's say we take the first sentence there. In 1900, tax receipts were 1.6 billion. In 2013, tax receipts were 5.7 trillion. Okay, sounds like taxes have gone up way higher. Okay, what we don't know though is maybe the economy has grown at the same rate and the population. We don't know that. All right, so maybe the raw numbers are not the helpful thing to let us know whether taxes have gone up a lot. So sometimes raw numbers are better, sometimes statistics are better. Between 2000 and 2010, cases of leprosy in the U.S. skyrocketed 200%. Wow, 200%, that's terrible, all right? Leprosy, what a terrible disease. But think about it. If we start off with 1 in 1 year, and then we have 2 the next time, that's a 200% increase. But you've only increased from 1 to 2, all right? Before. That would be a 200% increase, all right? Well, that's not so much. From 1 to 4 people is not that much. In 2010, 300 people in the United States, 0.000001% of the population contracted leprosy. Well, now it doesn't seem like so much. Why? Because now the raw number seems not so much. Leprosy is so uncommon, and it's such a tiny percentage of the population. Now here I'm using a percentage. So the effective use of numbers and percentages in the right way can make your case seem really terrible. Leprosy's all over the place, to very tiny. There's hardly any leprosy. Don't worry about it. Shootings in Chicago dropped by 17% in 2017. Well, that sounds good, okay? In 2017, 3,561 people were shot in Chicago, and 682 of them died. Wow, that looks terrible. Now, that was a decrease from 2016, but still, that's a lot of people. And so maybe raw numbers, again, make it look worse, okay? Whereas percentages make it look not so worse, not so bad. Comparisons are also very effective, can be effective. In Chicago, in 2017, a person was shot every 2 hours, and a person was killed every 13 hours. A person was killed every 13 hours. My gosh, sounds terrible. So these comparisons, numbers, raw percentages, they can be very effective at shading the information and make it prove your point that you want it to prove. So which of these concerns you? Pause these for just a second. Read them and think about them. So in the first case, the 1.1 billion, that sounds like a lot of money going to illegal immigrant households, okay? It sounds terrible. But as a percentage of the total cost, it doesn't seem so bad. So again, raw number versus percentages can really affect how your data comes across. And so you need to be really careful when you're reading somebody using a raw number or a statistic. Try to think through how could it be deceptive. Another one, raw number versus percentages. 242 million refugees in the world right now, okay? That's 0.03% of the world population. Doesn't sound like much. Total populations, now here's a comparison. Total populations of France, Italy, Spain, Canada, Sweden, Switzerland, Denmark, Finland, Norway, and New Zealand combined. Wow, sounds like a lot of people. All right, now graphs are also very effective, but also very deceptive. They combine the appeal of numbers with the appeal of images. Take a look at this. We have our homicide rate. Looks like it really skyrocketed and then plummeted. All right, boy, it looked really bad about 1970 to 2000. Really awful. Now, this is not exactly the same statistic or data, but it's pretty similar. Okay, so national murder rate from 1970, that's about the start date of that one to 2014. Okay, wow. It didn't look like it's such a big rise and fall. What happened? How did they make it look so bad here and not so bad here? So with graphs, you got to look at a couple things. One is you want to look at the low point. Notice the low point here is 4, so it looks like it's essentially 0. And the high point of the graph is 10, so it looks like it's 100%. So it looks like it goes from 0 to 100%. Is how it looks. Notice how it's all squashed together, a very short distance from here to here, from 1950 to 2010 is a very short space, okay? But from here to here, 4 to 10 is a very large space compared to what we did here. Notice here from 1970 to 2014 is a very large space. So I've elongated that graph, and I've scrunched it down so it makes it look, it's not going to go so high, right? Also notice here at the bottom number is 0. So there's a good big space here at the bottom. And the top doesn't stop at 10, the top, it stops at 12. So there's more room to grow, all right? So notice these two graphs are showing the same thing, but they have different rhetorical purposes. They're trying to prove something different. One's trying to prove that murder rate was really awful. This one says, well, not such a big deal. Framing your data really matters, okay? Notice this has a little title. It's telling you the main point. Immigrant households consumed more welfare than native households in 2012. And again, I have immigrant households and native. It looks really bad for those immigrant households, okay? They're just using up more services, all right? Here's even worse. Welfare use for illegal immigrants and native households in 2012. Okay, here my illegal, wow. They're just using all kinds of welfare, food, Medicaid, cash. I mean, just, it's terrible. So how can this be deceptive? One thing we can look at can help us think about this is our entitlement spending in billions of dollars. Notice most of our entitlement spending goes to Social Security and Medicare, all right? A smaller percentage goes to Medicaid, food stamps, and TANF. This is what we call welfare, essentially, okay? So, but notice they didn't include Social Security and Medicaid in these other graphs, okay? If I go back for a minute, Medicaid is in there. Food is really high. Wait a minute. Food is very small percentage in dollars. So how does this get so high? Well, this is the percentage of households. So 57% of illegal immigrant households get food stamps. That's still a lot, but it's different from saying it's out of a very small piece of pie, I guess is what it's saying, okay? Really much more concerned is Medicaid. There's a lot more cash going to Medicaid, and cash welfare and housing are very small to start with, okay? Notice what we're not counting also. We're not counting school, which is a public benefit. A lot of public benefits we're not counting, okay? Now let's take a look at a graph that's trying to prove something different. This is the member of a household receiving SNAP benefits. These are a kind of welfare benefit. Low-income adults, 2011. The native-born is this group. Wait a minute, native-born, wait, why are they taking more? It was just the opposite before. Naturalized citizens here, that's people who immigrated and became citizens, and these are non-citizens. It's not counting illegal versus legal, it's counting these two groups are immigrants, this group is native-born. How did that happen? How did they get that? Well, again, they've got their own deceptive and cherry picking of data. They're only counting low-income adults. So they're saying among low-income adults, native-borns use services at a higher rate than these other groups. And that really explains our other two graphs here, especially this graph, I think is probably less deceptive than the next one. Immigrants are going to use more services because they're poorer. Poor people use more services than non-poor people, and because there tend to be more poor immigrants, especially illegal immigrants, they're going to use more services. It's not that great a mystery. Okay, this shows the same thing among poor, low-income people. Native adults use more services than non-services than non-natives. Now again, we're only counting SNAP. They're not counting food stamps or other benefits that might not be included. All right. So the point is this. All right. Key principles. Make sure when you're writing, provide context, provide comparison points. Okay. Paraphrase accurately. Present your data effectively. Try using a statistic sandwich. And beware of your own biases. All right. Be careful how your own biases are going to creep in. You may be spouting off nonsense just because you want to believe it. And in the same way, watch out for others. When you read statistics, very careful. Watch out for the bias of the writer. Watch out for averages. What kind of average is being used and how it's measured. How terms are defined. Watch out for somebody cherry-picking data, ignoring evidence that's inconvenient and only picking and choosing the evidence that they want. Watch out for that post hoc fallacy, very common, okay? Assuming that something happens, another thing happens, therefore one causes the other. Watch out for the difference between a raw number and a percentage, and watch out for graphs that distort. Statistics are very powerful. Like anything powerful, they can do a lot of damage, and they can do a lot of good. And I hope you can use them for good, and beware when somebody's using them in a bad way.